Hello everyone and welcome to the CEM Year 5 Block 5 lesson number 8 on maths. My name is Luke Lloyd and I'm going to go through the lesson with you today. So let's have a look at the plan. So to start off with, we're doing basically numerical reasoning in our maths. We're going to look at some range of questions. We'll start off using the Let's CEM Maths Quick Practice Testbook. And we're going to go through and answer a few questions, talk about how we best set out our solutions, have a look at some of the ways of laying out maths. We're then going to complete some tests together. We're also going to have a look at using formulae because it's one of the areas of maths that sort of links in with algebra, links with a few other areas. And if you've not seen it before, it can be quite off-putting. But actually, once you understand how formulae work and how to manipulate them, it can become quite a lot easier. And then we'll again try some practice tests that put that into practice. So again, our objectives to answer multiple choice numerical reasoning questions under timed conditions. Again, that timing is really key, guys. So please make sure you are timing yourself. You're not starting early. You've got a clock or you're using some sort of device on your phone or on your computer or mum and dad to help out. Make sure we're timing ourselves. And then we're going to revise the different techniques in the maths. So we've got a couple of questions that I just want to go over. So how we find percentages and how many hours are there in April. We're going to talk about how we lay these out and how best to go about them. Percentages as a question type. I really like these questions. There's a couple of easy ways to do them. My advice is to split the percentage into simpler percentages. What do I mean by that? Well, let me show you. Instead of finding 61%, I'm going to choose to find 50%, 10%, and 1%. Because if I can find these three values and add them together, I'll have my answer. But I've chosen 50%, 10%, and 1% because they're much, much easier to work out. 50% means 50 out of 100. 50 out of 100 is a half. So if I want to find 50%, I need to find half of 200. If I want to find 10%, 10% is 10 out of 100, or 1 out of 10. So if I want to find 10%, I need to do 1/10 of 200. And if I want to find 1%, that is 1 out of 100, or 1/100th of 200. And so the key learning point here, and this really is the bit that matters, is that really I would recommend learning these conversions. It's a nice way to work it out and understand where it comes from. It's 50%, which is 50 out of 100, half. But really, I would just memorize 50% of something is half. 10% is dividing by 10, or a tenth. And 1% is dividing by 100. Because, hopefully, if you see here, if we work this out, half is 100, 1/10 is 20, and 1/100th is 2. When I add these up, my answer is 122. And that is the answer. But these are things I want you to learn. I want you to just know 50% is half, 10% is 1. And that now means, really, with 50, 10%, and 1, you can work out any number. The other one that might be worth thinking about is how would I go from 10% of something to 5% of something? Well, if you can work out 10%, just halve whatever it is to get 5%. So if 10% equaled, I don't know, 50, what would 5% equal? Have a think. Pause if you need a bit of time. It would be 25 because it's half. And so being able to find 10%, I think, is perhaps the most important, because really from 10% you can go to anywhere. Similarly, if I wanted to find 70% of something, I might work out 10% and times it by 7. So there's lots of ways you can manipulate these to work out and get to where you need to be. But certainly I think those three are the core ones. From there you can quite quickly get to wherever you need to. Right, that's our percentages. My recommendation of how to work out percentages. How many hours are there in April? There's a few things we need to know for this question. First off, we need to build up really from the month to the hours. So a couple of things you just need to know, need to learn. How many hours are there in a day? Well, there are 24 hours in a day. And the number of days in April is 30. And the very common way of remembering this is 30 days have September, April, June, and November. All the rest have 31, except February, which has 28 days, except on a leap year. I think the rhyme goes something like that. But if there are 30 then days in April, we can work it out. So what we've got here is the two facts. There are 24 hours in a day, and there are 30 days when it's going to be 24 multiplied by 30. Now, some of you guys might find easy methods. There's loads of different ways of doing it. I'm just going to show you a nice way that I like to see. I'm going to set it out, so let me just move these out of the way for me so I can see to the side. This method is I've heard called the lattice method. Essentially, you draw a box and you make sure there's a column and a row for every number. So what do I mean by this one? Let me show you. So 20 and 4 and 3 and 0. And then going from corner to corner, you connect every box up. And at the end, you just overextend a little bit, almost by another box worth. And then once you've got this set up, this is like you would in your column addition, setting up your column. It's then quite easy. You do 4 times 3, which gives you 12. Tens go on top, units go on the bottom. 2 times 6, sorry, 2 times 3 is 6, giving it away. 0, 10s, and 6. You just keep following. 2 times 0 is 0. 4 times 0 is 0. So that's your first step, and you might be thinking, well, why do we do this? Well, hopefully the answer will come clear in a second. You then add up down these diagonals. So in this diagonal, it's just 0. In this diagonal, I've got 2, 0, and 0, so that adds to 2. And this one, I've got 1 and 6. And now my answer, I read in this direction, so my answer is 720. And I like this method. There are loads of ways you can do it by column multiplication. I've seen people set it up with boxes where they divide the numbers into sort of 20 and 4 and 30 and 0 and so on. There's lots of ways of doing it. Whichever one suits you and you're quickest at is the best way. But the reason I like this method, I might as well show you, is it also works for decimals. So if I was to make this 2.4 times 3.0, my answer would be where this line points to. So my answer would be 7.20. That's a bit of a distraction, so I'll go back, but it's just a nice method that and that's why I like teaching this one. But let's go back. It wasn't decimal, so we can get rid of those. So the answer was 720. So there we go. So just nice skills. So with this one, the quick practice test book, you've got 5 minutes to complete test 8. Test 8 will look like this. This is the first example. Talks about rounding. Been over this exact example a few times, so I won't do it again with you now. But guys, go set yourself 5 minutes, start the timer, pause the video, and then come back when you're ready to go through the questions. Right, ready, go. Right, guys, welcome back. Let's go through the answers together. So, first off, I can just reveal the answers. A and C, and let's just talk about why. Question 1, we've seen this before, hopefully, percentages. 74% of 300. What would I have recommended splitting it into? Well, I might have worked out 50%. Maybe I'd have gone to 20%, or I'd have done 10 twice, and then I'd have worked out 1% and added that 4 times. So let's go through it now. So 50% of 300, I remember that, that's half. So half of 300 is 150. 20%, I might have maybe done in a couple of steps, I might have said 10% first. Well, 10% is easy, that's divided by 10, so that's going to be 30. So 20% will be 2 lots of that, so it will be 60. And I want to know what 1% is, well, that's going to be 3. So from there, I can work out 4%, which is going to be 4 lots of 3, which is 12. So now I work out the numbers I need to actually get to 74. Well, I'll need my 4%, my 50, and my 20, because that adds to 74. So I'm going to do 12 plus 150 plus 60. So 150 plus 60 is 210. And then 210 plus 12 is 222. So there's my answer A. How many hours are there in August? Very similar question. So again, go back to my rhyme. 30 days have September. All the rest have 31, which means there's 31 days in August. So it's going to be 31 times the number of hours in a day. And we know there are 24 hours. So the maths is 31 times 24. And 31 times 24 is 744. Based on what we did earlier, you can actually just add an extra 24 onto this, because we have got, instead of doing 24 times 30, we were doing 24 times 31. So it's going to be one more 24, one more day's worth of hours. Right, next question. And again, just for that, remember guys, I don't mind how you multiply. You might have done it in your head even, and that's absolutely fine. If you can do it in your head accurately, all the better because it's nice and quick. Right, number 3. So let's go over the answers. The answers are C and E. Let's talk through them. Toy shop displays this sign. Toys are priced at £4.80 each. How much would 10 toys cost? Well, if each toy is 4.80, you'd think it would just times by 10. But you've got to remember this. Buy 4 toys and get the 5th one half price. So the way I'm going to work it out is I'm going to say I want to get to 10 toys. So I'm going to need to do this deal twice. So I'm going to have 4 normal cost ones plus another 4 normal cost ones. So that's 8 lots of the £4.80. But I'm also then going to have 2 half-price ones. But I think rather than having 2 half-price ones, if I added those together, that would be the same as 1 full-price one. So I'm actually going to jump straight to saying this is the equivalent of buying 9 toys at full price. Have a think about that for a minute, see if that makes sense to you. So instead of buying 10 at full price, because we're going to, for every 5th one, and to get to 10, that means we're going to have 2 of these 5th ones, it means we're going to get 2 of them at half price. Well, that's the same as just not paying for one of them. So we can now work out this sum. 9 times £4.80. Again, since we're talking about different ways of working things out, I might be tempted to do 10 times £4.80. I can do quite quickly. I could do it in my head, and you wouldn't hopefully need to set this out. Although, guys, I'm trying to write out more working now for people who are following on at home who need the extra help, not necessarily to show you the working I would expect you to have to do in the exams. If you can do less working than I can and still get the answer, brilliant. So 10 times 4.80 is 48. Well, that's 10. I didn't want 10. I wanted 9. So if 10 of them is £4.80, 9 means I just have to take away £4.80 worth. And the way I would take away £4.80 in my head is I'd do 48 take away 5, and I'll add 20p back on. So 48 take away 5 is going to be 43, and add on the 20p, it'll be £43 20p. And I can just check, go back the other way. If I added my £4.80, would I get back on? Yes, I would. So there's my answer. £43 and 20p. Add the pound sign in. So with this one, to speed myself up, I used a couple of things. I was interpreting the information that the question gave me, and then I was using some tricks to try and do some faster working out. I think that's quite important. Right, number 4. 400 books were sold in week 1. During week 2, there were 10% less books. In week 3, there were 10% more books. Let's go through it. So, in week 1, full stop. I'm doing full stop to indicate it's different. We had 400. In week 2, we had 10% less. So I have to do some maths. What is 10% of 400? Well, we know that. It's dividing by 10. So it's going to be 40 less. So 40 less doesn't mean the answer is 40. It means I have to take it away. So the answer was 360. And in week 3, 10% more books were sold than in week 2. So this is where it gets difficult. I can't just add my 40 back on. I've got to work out what is 10% of 360. And this might surprise a few people. If we do the maths again, 10% of 360 is divided by 10, so it's 36. So it's saying there were 10% more, so it's 36 more. So I'm going to add 360 and 36 together. So let's do it. 360 plus 36 is going to be 300. 6 and 3 is 9. 396. So how many books are bought in week 3? 396. And I could see this one confusing people. It will certainly catch a few people out. The reason is you've got to go with percentages. It's very important you define what you're starting on. So that's not divided by 10, but that should be actually written minus 10% or 10% less. So going from there is 10%. But where we were working out 10% of 40, to go from here to here, it's not 10% of the 10% of the 400. So this was 10% of the 400. This was 10% of my 36. And that's really important that we're not sort of forgetting our steps. So when it was talking about 10% of week 1, that was 40. But when it was adding 10% of week 2, that is 10% of week 2, which is 36. Hopefully that makes sense. 5 and 6, real our answers. D and E, so the average speed of over 5 hours was 110 kilometers. The average speed of the train for the first 3 hours was 90. What was the average speed over the last 2? Oh, I love this kind of question. So the average speed in total was going to be 5 times, or sorry, the total distance covered, that's another way of saying it, was 5 hours at 110. That means it's going to be 5 lots of 110. That will tell me how far they've gone in total, which is 550. In the first 3 hours, they covered 3 hours at 90. That's 3 lots of 90. It's going to be 270. So the difference between these two distances, is what was covered in the last 2 hours. So I know that if I can work out the difference and divide it by 2, that must have been the speed per hour they covered. So we'll do 550 minus 270. And 550 minus 270 is going to be 280, I want to say. And if we covered 280 in the 2 hours, the speed must have been each hour 280 divided by 2, which is going to be a total of 140 kilometers per hour. So that's your answer. Again, just to reiterate a couple of things that are important. This one's about understanding the distance between the relationship between speed, distance, and time, and the fact that if you're doing 5 hours at this speed, means we did 5 lots of 110, will give us the total distance. So that was our total distance. It was 550 kilometers they've gone. It then said that for the first 3 hours, they were 90 kilometers per hour. So if they did 3 hours of 90 each hour, that's where we got the 270 kilometers from. So the remaining 280 kilometers had to be covered in the last 2 hours, but the speed means how much per 1 hour. So if we had to do 280 in 2 hours, we must have done 140 in 1 hour. Hopefully that makes sense. Question 6. The table shows the number of books read per week by 4 children. How many books do the 4 children read in 4 weeks? Okay, so underline the key bits for me. So it's 4 children, 4 weeks, and it's books per week. So Adam does 4 books per week. So he in total is going to do 4 books times 4. Duncan does 2 books a week, so he's going to do 2 over the 4. Beth does 3 books a week, so in 4 weeks' time she'll have done 3 times 4. And awesome Sally, love to see it. She reads 5 books a week, which is amazing. So she's going to do 5 times 4. So in total, all I have to do is work out my multiplications and add them up. So it's going to be 16 plus 8 plus 12 plus 20. And I'd add my 8 and 12 to get 20, 20 and 20 to get 40, and then 40 plus 16 to get 56, which is my favourite number. And that's how I'd work it out. Right, I think last page of questions. Reveal our answers. Whoop. So, in a class of students, there are 18 boys, 13 girls. 9 students have brown hair, 14 wear glasses. What's the largest possible number of girls who have brown hair but don't wear glasses? Interesting questions. So, there are 18 boys and 13 girls. Well, the largest possible number of girls could be 13. It can't be more than that because there are only 13 girls. So I'm just going to jot that down so I remember. 9 of the students have brown hair and 14 of the students wear glasses. Well, in total, if 14 wear glasses and there are 18 boys, that could be 14 boys. So I think the answer... Oh no, 9 of the students have brown hair and 14 of the students wear glasses. What's the largest numbers who have brown? Oh, there you go. It's not me reading it. So yes, I was. So there could be. So all the girls could have glasses, all the girls could not have glasses because it could be 14 boys wearing glasses. and then 9 of the students have brown hair, all 9 of those could be girls. So the largest possible number could be 9. Final answer. That's me not reading it correctly, so I had to do 2 bits of maths, not just one. But it's always good to see. And that's why we always go back and check the question and read it again and again. So, Tim is a salesman at a television company. Every month he is paid a base salary of £750 with 25 commission on the value of each television that he sells. In June, he sells 5 televisions with an average price of 400. That means on average, each one costs 400, which means he did 5 lots of 400 in total because he sold 5 of them, which is £2,000 worth of televisions, which is a pretty good effort. And commission. Commission means he gets paid 25% of the money he makes. Well, that's going to be 25% of 2,000, which is actually going to be, again, just for those working it out, you could do 10%, 10%, and 5%, or you could learn that 25% is a quarter, and a quarter of 2,000 is £500. That means he's going to earn a bonus £500, so I've now just got to add what he was earning, the base salary, plus his bonus, which is going to be the answer of 1,250. I think that's about understanding keywords. So you might want to add commission into your books, and to commit your commission as part of your salary is money you get paid as part of earning. So I think, for example, people who sell houses sometimes get commission, and car dealers can get commission. Often salespeople will be referred to as doing things for commission. Harry rode his motorcycle 150 kilometers in 2 days. He rode 4 times as far on the second day. How much further did he ride? Well, he did 150 kilometers in 2, but he did 4 times than that on the second day. So, in total, it's 150. But I'm looking for a number that so I need 2 numbers that add together to make 150. But my first number needs to be 4 times smaller than my second number. So I'm just going to see in my head, what does 25 sound like? So if he did 25, that would be 25 plus 4 lots of 25. No, that gives 125. Not enough. So I'm now going to think, well, what about 30? If he did 30 on the first day, then he did 4 lots of 30. That would be 120. It does add up. And since 30 plus 120 adds up, that's the only numbers that can work. We can use 150. And I want to know how much further he rode. I can just work out the difference between the two. And remember, the difference in maths always means take away. So the difference is 90. So final answer, 90 kilometers. Now, how did I do that? You heard me do it. It was trial and error. I picked a number that I thought was approximately right. I was looking at 150 and thinking, okay, well, I need to be able to fit 4 of them and another. So it's going to be split into 5 things. Another way you could have done it, I suppose, is to do 150 divided into 5 pieces, which would have given you 30. Why 5? Well, because he's doing 1 lot on the first day and then 4 lots of it on the second day, which is a total of 5 lots. But with that one, I think it's very trial and errorable, as you just saw. Right, guys and girls, can I please have scores written down, shown to mum, put on the fridge, jump up and down, have a little stretch, relax, and we'll move on to the second activity. For this one, we're going to talk about this formula. It's a very common formula. It is speed equals distance divided by time. Let's talk about it. First off, speed, what do we measure that in? Often in kilometers per hour in this case, or meters per second. There's lots of units. It doesn't matter what you're doing, as long as you're being consistent. In this case, it might be minutes or hours, but if we're talking about kilometers per hour, and this is in minutes, we have to have a think about that. Distance, well, measurements of distance would be, again, meters, kilometers. They're the most common. Time, you could have anything from seconds, minutes, hours. The important thing to remember with these is, as long as you're consistent, as long as you use the same units for all of them, they will work. It goes wrong when you start putting in minutes and taking out hours, because unfortunately, if you put in minutes, you'll get out minutes. What do I mean? Well, let's have a look. Train A covers a distance of 180 kilometers in 60 minutes. So it's 180 kilometers in 60 minutes. So I wanted to work out the speed I could do 180 kilometers divided by time, divided by 60 minutes. Well, yes, but then that would give me kilometers divided by minutes, or kilometers per minute. But I don't want kilometers per minute. That's not what my car says. My car will do kilometers per hour. So instead, I'm going to do a conversion straight away. And I'm going to say, in 60 minutes, that's an hour. So I'm going to do mine divided by hours, which will give me kilometers per hour, which is what I want. So the first train goes at 180 divided by 1, which is 180 kilometers per hour. kph. Oh, that h doesn't look very good. Kilometers per hour. Train B covers the same distance in 180 minutes. Well, the distance is going to be 180. So he's done 180 kilometers in 180 minutes. That's the same thing as saying 3 hours. So his speed is going to be 180 divided by 3. That's 60 kilometers per hour. What is the average speed of the two trains? Oh, well, I was already working that out. So the average speed, or the speed, will be in 1 hour, he did 180 kilometers per hour, and this one did 60 kilometers per hour. And if you think about what you've just said, train A, we know it goes 180 kilometers, and we know it does that in an hour. So to say it goes 180 kilometers per hour makes sense, because in 1 hour it did go that far. Train B took 3 hours to go 180 kilometers. So you could say it went 180 kilometers per 3 hours, but we don't use that. We want per 1 hour. So we divide it by 3 to say it went 60 kilometers per hour. And it did that 3 times to go 60, 60, 60 and cover the 180. So there's my answers. But again, the big thing is, I notice how I wasn't dividing with this. I was converting always to my useful units, which is in this case hours. Why? Because the question it said hours. And this was 3 hours. And I was then using hours as the time, not minutes. If these questions go wrong, 9 times out of 10, it's because you've not converted it to minutes, or you're working out how far it went, and it went 1,000 meters rather than 1 kilometer. Things like that, they can often throw your answers off. So, what are we doing? Start by solving question 1 in test 9. Okay, well, that's what we would have done in the classroom, but you know what? I think we'll go through that together as a team. Here's test 9. Let's get going. You've got 5 minutes to do 10 questions. Again, guys, time is ready. Pause me and come back when you're ready for some answers. Good luck, everybody. Off you go. There goes the timer. Right, guys, timer's up. Welcome back. Let's go through some answers together. So here are my answers, question 1 and question 2. So we've got 18 and 124. Let's talk through them. Book 5 costs the same as 3 pencils, 2 pens cost the same as 1 pencil, and 3 rubbers cost the same as 1 pen. Oh my goodness. How many rubbers cost the same as 5 books? Well, let's see if we can link it. 5 books is the same as 3 pencils. I'm going to do lowercase p for pencils and capital P for pens. So I'm going to label that so I don't get confused. 2 pens cost the same as 1 pencil. So 2 big P's is the same as 1 lowercase p. And finally, 3 rubbers cost the same as 1 pen, which is a big P. So really, we can work down. It doesn't really matter which difference. Let's try going, well, let's go through. So 5 books buys you 3 pencils. 3 pencils would get you, well, 2 pens the same as 1 pencil. I think with this one, guys, it's better to go in reverse because I think it's easier. So let's start off really quickly. So, well, actually, no, let's continue on. So 5 books gives you 3 pencils. But for every 1 pencil you have, it gets you 2. But we don't have that. We have 3. So if that means now using the same maths, 3 pencils will be worth 6 pens, twice as much. And then 1 pen gets you 3 rubbers, but we have 6. So instead I want to have 3 times as many rubbers. So I'm going to have 3 lots of 6, which equals 18. So final answer. Oh, there you go. It was 18. It's good to see. 18 pencils. If I was to go in reverse, how would I do it? I'd say, well, 3 rubbers for 1 pencil. No, I think you had, guys, I do think it's better to start with, you had 5 books, which gets you this many pencils. You know that 1 pencil sells for 2, so you're getting now twice as much. And then you know again that 1 pen goes for 3, so you're getting 3 times as much. So what you've basically done is you've done 3 times 2 times 3 again. Right, next question. Number 2. Which number comes next in this sequence? 0, 7, 26, 63. Oh my goodness. Right, well, what's going on here? We've got a difference of 7, then we've got a difference of 19, then 63. So it's not jumping out straight away. Are we doubling our answers? No. What's the gap? I think I'm going to have to write this one down. So, plus 7, plus 19. The difference between 26 and 33 is going to be 36. Now that I've got these numbers, I'm going to look at what's called the second difference, which is the difference between them. So to go from 7 to 19, the difference is going to be 9 plus 3, which is 12. And then 36 and 19, the difference is going to be 17. So would my third difference be 5 more? Would it be 22? So 63 plus 22? I don't think it is because it says down here. So is this a sequence that I should recognize? Are we doing 7 times 26? No. So I'm not timesing the sequence before. What's going on here? Well, I think I'm going to have to check my magic book and see. I'm not sure with this one. So this is test 9. So look at test 9. See what it says. I'm intrigued. Test 9, question. Maybe that far. Question 2. It's the cube numbers minus 1. Oh, yes. Well, I should have spotted that. So my cube numbers, guys and girls, so there's, you know what? Now, it's always when I say it, it's obvious. My square numbers are, so my square numbers are sort of classic. It's 1 times 1, 2 times 2, so it's 2 times 2, which is 4. 3 times 3, which is 9. You could do 6 times 6, which is 36, and so on. So they're my square numbers. My cube numbers, not a very good drawing of a cube, it'll do, would be, for example, 2 times 2 times 2, 3 times 3 times 3, and in this case, 6 times 6 times 6. Again, they're one of the most common sequences, and I should have thought of that, to be honest. I think it was no excuse. So in this case, what are my cube numbers? Well, they are 0, 8, 27, 64, the next one 125, and if you look at this sequence here, all of these are just 1 less than that. How tricksy. So in this case, the answer would be 124 because it's 1 less than 25. Tough question, good question though, and just one that I think is well worth seeing. And with your cube numbers, certainly worth learning the first 5, maybe even as far as your first 7, 8, 9, 10, see how far you can get. 10 times 10 times 10, that's quite a tough one, but I'm sure you can handle it. Question 3. Henry wishes to cover his garden with pieces of turf. Each piece of turf measures 25 centimetres by 20 centimetres. This measurements of the garden are shown below. How many bits of turf will he need to cover the whole garden? So he's got bits of turf that are 20 centimetres times 20 centimeters. That's the area of them. I'm timesing the width by the height. And they need to cover the area of this entire thing, which is going to be 5 meters times 4 meters. This is a problem. We've got centimeters and meters. So there's a couple of ways to do it. We could turn everything to centimeters, which might be easier, or we could turn everything to meters. I think it depends. What's going to decide it is what my area in centimeters looks like. If it's a nice number that I can easily convert to meters, I might do that. Well, 25 centimeters times by 20. This one I would split into timesing by 2 and timesing by 10. That's the same thing as timesing by 20. So 25 times by 2 is 50, and then times by 10 is going to be 500. So that means each one will cover 500 centimeters squared. Let's see now here, I've got 5 meters, which is the same as 500 centimeters, times by 4 meters, which is the same as 400 centimeters. So the area of my whole thing will be, well, 5 times 4, which is 20. And then I'm timesing them both by 100. So I've got to do 500 times 400 is going to be 20. 1, 2, I think, and 3, 4. Yeah, so that's going to be 200,000 centimeters. So it's indeed a squared. So what we've done here now, which is a bit tough, is we're going to now work out how many 500 centimeters fit into my 200,000. Now I'm going to set this out and just show you a cool trick with division. When you're dividing things like this, and you have zeros on the top and the bottom, you can actually cancel out to make the sum easier. So 200,000 divided by 500 is going to be the same as 2,000 divided by 5. And 2,000 divided by 5, well, if I did 20 divided by 5, that's 4. But it's not the same thing as 20. It's with some zeros on the end. So I've got 2 zeros on the end, so I've got to say it would be 400. So we would need, or rather we would need the 500 centimeters fits into the 200,000 400 times. So we would need 400 bits of turf to cover the garden. Tough question, but really important that we compared both in the same. You could have done equally, you could have done it in centimeters, you could have done it in meters, then this would have been a much smaller number, and so would this, but the difference would still be 400 times. Another question, just a bit of tough multiplication. Calculate 586 times 79. How would I do this? Again, I would probably just go straight to my trusty method. And 5, 8, 6, 7, 9. Drawing really carefully. And as we go through, just going to pick a slightly thinner pen. 6 times 7. You can't do 6 times 7. I know some people struggle with it. You could do 5 times 7, which is quite easy. That's 35. Then add another 7 on to get to 42. 6 times 9, again, some people struggle with their 9 times table. So you do 6 times 10, that's 60, but then take 1 6 away, you drop down to the correct answer, which is 54. Some cool ways of doing mental maths. 8 times 7, again, lots of people will learn 8 times 8, which is 64. So if you do 1 less, you can drop back down to 56. Great to have times tables. If you know a couple of them, you can kind of work your way to get the rest. 5 times 7, that's the one that people quite commonly know, although, hang on, I've forgotten my little line. So 5 times 7 is 35. Then I'm going to do my 9 times tables again. I like my 9 times tables because it's just 1 less than the 10. So 80 would be 8 times 10, but I want 8 less than that, so I want 72. And of course 50, but I want 5 less than that, so it would be 45. And now this is where I'm just going to grab this and move it up a bit so everyone can see my working nice and clearly. Let's put it there and just move you out of the way for the moment question, if you don't mind. Thank you. And now we add down our columns. So we've got 4 in this one. Not columns, I should say, they're some more diagonal ones. I've got 2 plus 2 plus 5, so that's 9. I've then got 4 plus 6 plus 5 plus 7. Well, that's interesting, it's going to be over 10. We'll see what happens here. So 4 plus 6 is 10, plus 7 is 17, plus 5 is going to be 22. So we carry the 10s up here. We write the 2 units here. And now 5 plus 5 is 10, plus 4 is 14, plus the 2 is 16. So I carry the 1 and write 6. And then 3 plus 1 is 4. So final answer, 4, 6, 2, 9, 4. Let's just check our answers. Whew, got away with it. 400 and 46294. 46294. And that's how I'd work them out. Next page. So, how many minutes are there in one day? Oh, cool question. So the facts I need, there are 60 minutes in an hour. And there are 24 hours in a day. So it's going to be 64 times 24. Again, many ways you could do it. You could sit out at the bus stop. Is there an easier way perhaps? Well, if you did 6 times 24, and then whatever that answer is, you then take that answer and times it by 10. That would get you there because we've times it by 60 is the same as 6 and 10. So how would I do this? Well, I could do 6 times 20 is going to be 120. 6 times 4 is 24. So if we do add those together, you get 144. And then if you do 144 times by 10, you end up with 1,440, which is my answer. Or you could just go straight there. That works too. Next question, number 6. If we've got, let's clear some space. If we've got, Jane has a collection of 480 marbles. That is a lot of marbles. A third of them are blue, an eighth of them are red, a fifth of them are yellow. The remainder are green. Oh, that's a cool question. So you've got a third plus an eighth plus a fifth plus something plus something adding to the total of 1 out of 1, which is your fraction. So I want to work out how many are left. The way I'm going to do that is I'm going to work out what these fractions are added up, and I'm then going to take that away from 1. Or I'm going to then work out what I would need to add to make it be 1 out of 1, or the full fraction. The way to do that is to find the highest common multiple of all of these. There's a load of ways you can do it. You could do 3 times 8 times 5. That would work. You can have a think if you know any number that's in your 3 and 8 and 5 times tables. But I think the easiest is for me, so I'm going to just times them all together. So let's do 8 times 5 first, which is 40, times by 3, which is going to be 120. So if I make all these fractions out of 120, they'll be what's called equivalent. And I can then add them all up without a problem, because you can only add equivalent fractions where the denominator is the same. So what do I have to times 3 by to make it 120? Well, I times it by 8 and 5. So I'm going to have to do the same thing to my 1. Well, 1 times 8 is 8, and 8 times 5 is 40. What did I do to 8 to make it 120? Well, I times it by the other two, which is 3 and 5. So I now have to do 1 times 5, which is 5, times 3, which is 15. And a similar story, what did I times 5 by to make 120? Well, I times it by 8, and I times it by 3. So 1 times 8 is 8, and then 3 times 8 is going to be 24. So now that I've worked out what my fractions are and I made them equivalent, I can add them all up. So I know that out of 120, all of these weren't green. So let's add them together. So I've got 40 plus 24, that's going to be 64. 64 plus 10, 74. 74 plus 5 is going to be 79. And if 79 of them are one colour, 120, what's the remainder going to be? Well, if I do 120 which is the same as 1 out of 1. It's the same fraction, minus 79 out of 120. I can work out what the remainder are. It's going to be 20 plus, it's going to be 41 out of 120. Will be green, but I don't have 120. She doesn't have 120 marbles, which is just a fraction we've been using. She has 480 marbles. Luckily, I think there'll be a way of making my 41 over 120 be out of 480. So I've just got to ask myself, how many times bigger, how much more would I need to do to go from 120 to 480? Well, it's 4 times bigger. So to keep my fraction equivalent, 41 times 4 will get me to the same place. So how do I do 41 times 4? I do the 1 times 4, is 4, and then 40 times 4 is going to be 160. So now, the way I would read this, 164 out of my 480 will be green, so my answer is 164. Not that fraction, that's just what that's telling us. And there's my answer. Whew, right, we're getting there. Question 7. Train A covers a distance of 120 kilometers in 60 minutes. Train B covers the same distance in 120 minutes. This sounds familiar. What's the average speed of the two trains in kilometers? Very similar. So 120 in 60. Bear in mind that 60 is the same as saying 1 hour, will be 120 kilometers per hour. So that's train A. Train B is going to go the same distance in 120 minutes. So it's done 120 minutes. Let's do it this way. 120 in 120 minutes, that's 2 hours. But let's write it this way, let's just clear it up. So 120 in 1 hour is 120 kilometers per hour. 120 in 2 hours is 60. 60 kilometers per hour. H is always difficult to draw. So what was the average speed of the two trains? The average of the two trains will be between them, the bit between the two of them. So if I've got one train going 120 miles per hour and the other going 60 kilometers per hour, the average, as we know, is another way of saying the mean. So to do that, we add them up and then divide whatever that answer is by 2. So let's do it. So 120 added together is going to be 180. 180 divided by 2 is going to be 90. Kilometers per hour. Let's try that again. Kilometers per hour. Hey, 90 kilometers per hour. And then how many factors does number 36 have? Oh, I like this question. The only hard part really is working out what factors are. Well, multiples are times tables. Factors are numbers that you can multiply together to get that answer. So I always think of factors as factor pairs. So if I go through and make myself what's called a factor bug, I'm going to start at 1. And yes, 1 times 36 will give you 36. Then I'm going to do 2. So 2 times what? Because I have to work out the pair, goes 36. Well, 2 times 18 will be 36. And I can try 3. 3 times something, yes. 3 times 12. Can I times 4? Yes, I can. 4 times something will equal 36. 4 times 9. Can I do 5? Oops, sorry, 4 times. Yeah, 4 times 9. No. Can I do 5? No. Can I do 6? Yes, I can. I can do 6. 6 times what? 6 times 6. With when you're doing factors, you wouldn't write the same number twice. And actually now, once I've come to 6, once I've met up my numbers on the other side, in this case 6 is obviously 6 and 6 are the same thing, I've reached all my factors. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is said there. 9 factors, my factor pair. And these are called factor bugs. And basically the rule is you just start around, so let's do another example really quickly. So we had 12, you would do 1 and 12. You could do 2 and 6, 3 and 4, and then obviously you did 1, 2, 3, and the next number to try would be 4, but that number's already on this side, and that's a signal to finish because you know you've got there. So that's how you do these factor bugs, which is quite cool. Right, last page is a good thing too because my voice is starting to go. Number 9, on the right to the grid, 1 unit represents 3 kilometers. That means this is going to be 3 kilometers. Okay. Alex starts a journey at point G. He travels in a straight line to 1, 2. So the rule is along the corridor, up the stairs. So that's where he travels. And then a straight line to 1, 6. So 1, 6. How many kilometers does Alex cover? Well, he goes 3, 6, 9, 12, 15, 18. 18 kilometers. Really good. And the last one, a faulty clock runs 120 seconds fast per hour. So I'm going to say, already going to convert that to be more useful to myself, 2 minutes fast per hour. So for every hour that passes, it will gain 2 minutes. So if the clock currently shows 3:54, what will it show in 4 hours? Well, in 4 hours, it's going to show the plus 4 hours. So we've got to work out what that will look like. But also, it's doing an extra 2 minutes per hour. So we need to add on 4 hours, and we need to add on 4 lots of 2 minutes. So 8 minutes. So my clock will show 4 hours more and 8 minutes more. So now how will that work? Well, I'm going to do the minutes parts first. So if we say from 54 plus 8, that will take me to 4:02. And then at 4:02, so that's that bit done. And 4:02 plus 4 hours will be 8:02. Final answer, 8:02. Right, guys. Whew, tough stuff again. Well done. Give yourself a score out of 10, or how many questions there were. 10 in this case. And just have a quick look for me. Here's the homework for me in my maths, test 3. It's tests 10, 11, 12, 13, 14, if you can, in the maths test book. And guys, with maths, really, the secret is the more practice, the better. Remember, of course, you're more than welcome to watch this and attend a live session. So any live session, of which you can find the timetables in the photograph section of the live group, where there was a post. And they've also been emailed out to mums and dads. At the end of every live session, either myself or Chris will be there waiting to answer you some questions. So please don't hesitate to come down. Right, everyone, thank you so much. We really appreciate your time, obviously, and hopefully it was useful. All the best, and see you next week. Bye-bye.